Hello everyone. So in this video, we're going to continue the discussion on this concept, the definite integral as area under a curve. In the previous video, we ended it by solving one example using this definition. And in this video, we're going to discuss this further. Okay. Now, this definition is, or this method is actually known as the method of Riemann sums, wherein we're using rectangular strips. Now, if you have the time, you can research on this method further kasi iba-iba yung approach nito. Merong left endpoint, merong right endpoint, but in particular, ang diniscuss natin dito is yung general method. Okay? Meron ring other shapes na ginagamit or kino-consider such as the trapezoidal groove. Okay, but we won't really discuss that further kasi eventually we're going to develop another technique on how we're going to do this more efficiently. Okay, so let's have more examples of using the Riemann sum to solve the area under a curve. Okay, now let's have this case. This is the graph of y equals x, this time from 1 to 4. So kung mapapansin nyo from the previous example, yung y equals x, binawasan lang natin ng bahagya. So we want the integral from 1 to 4 of x dx. This is the limit as n approaches infinity. The sum I running from 1 to n ng f of x sub I dx. Okay, in the general sense, delta x, this is b minus a over n. So, yung interval na to, divided by the number of rectangles. In this case, that is n. So, dito, this is 4 minus 1 over n or 3 over n. Now, how do we get the x sub i's? This one is a more complicated case than the previous one since yung una, nagsimula tayo sa 0. However, our initial x value here is 1. So, we have to consider that. So, that would mean that x1 or x sub 1 is 1 plus delta x. X sub 2, this is x sub 1 plus delta x or 1 plus 3 over n plus 3 over n, which in turn will give us 1 plus 6 over n. Now we can continue this one by getting x sub 3. This is x sub 2 plus delta x, so that is 1 plus 6 over n plus 3 over n or 1 plus 9 over n. So hopefully nakikita na natin yung pattern dito. We can generalize this as, let's just erase this to make space. X sub I equals 1 plus 3 over n I. Okay, so since we have f of x equals x, this would mean that f of x sub I would be 1 plus 3 over n. So we have delta x and x. We can continue. So that is the definite integral from 1 to 4 of x dx. This is the limit as n approaches infinity of the sum of f of x sub I times delta x. Okay, now similar to the previous example, ang ginawa natin ay inilabas natin yung n kasi ang nag-a-adjust na value dito is yung value ng I. So we can do the same. Pwede nating ilabas itong part na to. So this would give us the limit as n approaches infinity of 3 over n times the summation of 1 plus 3 over n. Now, if you would recall that if we have the summation of a plus b, we can actually make this as the summation of a plus the summation of b. Or in short, the summation notation or the summation operation is a linear operator. So, pwede nating paghiwalayin itong dalawang ito. So, if we do that, we have the summation I running from 1 to n ng 1 plus the summation of I running from 1 to n 3 over n I. Okay, now this part here, technically we're just adding n number of ones. So we can say that this is equal to n. Na itong part na to, similar to this one, pwede na nating ilabas yung 3 over n. Then, meron lang tayong summation ng I. Then, as in the previous video, we have this one. Which we have encountered before. Okay, so let us proceed. Limit as n approaches infinity ng 3 over n. As I've mentioned, this is equal to n plus 3 over n. Then the summation of I from 1 to n ng I is n times n plus 1 over 2. Okay, if we solve this one, this is limit as n approaches infinity of 3 plus 9 over n squared times n times n plus 1 over 2. Then of course, we have to remember how to solve limits. This one, same yung power ng numerator at denominator. So we just have to get the ratio of the leading coefficients. So 3 plus 9n squared plus 9n over 2n squared. So if we solve this one, this is equal to 9 over 2. So So we have 3 plus 9 over 2 or 15 over 2. So ito yung area ng region natin. Now, if we want, we can actually just treat this as a trapezoid kung saan i-extend natin hanggang 0. Remember na ang area nito ay, the entire thing ay 8. So, ibig sabihin, we just have to subtract the area of this smaller triangle and we should still get 15 over 2. Okay, now let's have one last example for Riemann sums. Okay, suppose we have this area or this region that is y equals x squared plus x plus 1. And we want to find the integral from 0 to 1 of this function. So using the definition or using Riemann sums, this may be written this way. If we're going to solve for delta x, again, that is b minus a over n, or in this case, that is 1 minus 0 over n, or 1 over n. Since we started at 0, hopefully we can recognize that x sub I can be written as I over n. So this would mean that f of x sub I would actually be I over n squared plus I over n plus 1. It's going to look intimidating, pero we can just treat this term by term. Our f of x sub I would be I squared over n squared plus I over n plus 1. Sulat lang natin siya as a single fraction. So I squared plus in plus n squared over n squared. Okay? So if we proceed, so again, that is from 0 to 1 ng x squared plus x plus 1 dx. So ito ay, this is limit as n approaches infinity of the sum of I squared plus in plus n squared over n squared times I over n. Oops, sorry, this should be 1 over n. Kasi delta x natin ay 1 over n. Okay, so similar to the previous examples, pwede natin itong ilabas. Isama na rin natin yung n squared sa denominator. So limit as n approaches infinity, we have 1 over n cubed ng summation. Ito na lang ang natira. So again, we can use the fact that the summation is a linear operator. So pwede natin paghiwa-hiwalayin yung terms. Okay, if we consider this part here, we're taking the sum of n squared n times. So may ito magiging n cube na lang. Oops, lagyan ko lang. Ganito. Okay? This part here, we can think of this as n times the summation of I from 1 to n, which we know as n times n plus 1 over 2. Oops, meron tayong n dito, so wag natin kakalimutan. Times n. And last, this part here, if we recall the sum of this of the first n squares, this is actually equal to n times n plus 1 times 2n plus 1 over 6. Okay, so having said that, this one is equal to the limit as n approaches infinity of 1 over n cubed times, we have n times n plus 1 times 2n plus 1 over 6 plus, gawin ko na tong n squared times n plus 1 over 2 plus n cubed. Okay? Solving this limit gives us, this is degree 3, this is also degree 3, and this one, if we distribute, magiging equal sa 1. Yung leading coefficient dito would be 2. Leading coefficient dito would be 1. And ito, 1 lang siya. So, ibig sabihin, diretsuhin na natin. This is equal to 2 over 6 plus 1 over 2 plus 1. Or 1/3 plus 1/2 plus 1, which is equal to 11 over 6. Now, you might be wondering, sir, are we always going to use this one? The short answer is no, for it is not efficient. Tapos, may mga cases na mahirap i-express as this one. Kasi dito, gumamit lang tayo ng mga known sums for us, such as the sum of the first n squares or the sum of the first n natural numbers. So eventually, we're going to discuss a technique in order for us to get the area under the curve easier and more efficiently.